So now we're going to work on our first script and we're going to get our camera to start moving. This is one of the reasons why we imported a package called Joystick Pack. Okay, so if I double click on Joystick Pack, it does have some documentation which you are free to read through, and it explains how to use this. We do have a number of prefabs. Okay, so the one that we want to go with is a fixed joystick. The difference between these: dynamic joystick will appear wherever you press your finger. Floating joystick can float anywhere as well, and the variable joystick, obviously it's variable, you can change those items. Fixed will always stay in the same position, or at least that's what I understood when I read the documentation. So in order to work with a fixed joystick, we need it to be a UI element, or a user interface. All of your UI elements are going to fit on a canvas. So we need to create ourselves a canvas. So let's click Game Object, UI, and a new canvas. Okay, as soon as you do that, you get a canvas and an event system. The event system is basically what is going to detect your touching of the items and interacting with those elements. It's using a standalone input module. Okay, if you ever wanted to switch any of your UI elements off, you just basically uncheck that. You can no longer interact with your canvas. Okay, but I'm quite happy to do so. So canvas, the first thing that we noticed about it is that the render mode is screen space overlay. So that basically means it will always be exactly the same and render over everything. If you did change that to screen space camera, basically means it's only available on certain camera. So you could switch cameras and the UI would then disappear. Or world space means you could actually have a canvas inside of the world that takes on a 3D location. That's useful, for example, if you wanted like a health bar over your characters. But we're going to stick with screen space overlay. Target display, always make sure it's display 1. That's what we're using up here. If we went to display 2, that's what it's showing. Display 3, there's literally nothing rendering there. So let's make sure it stays on display 1. Additional shaded channels, yeah, just leave it at nothing. Now, very importantly, our canvas scaler at the moment, UI scale mode, is constant pixel size. So even though this is 1280 by 720, if we create our UI and get it all lined up, and then somebody's got a mobile device that's say capable of running at 4K, 3860 pixels, what's going to happen is your UI is going to be absolutely tiny. All right, it's going to be so small you're not going to be able to interact with it. So I'm going to change this to scale with screen size, and I'm going to use our dimensions as a default reference resolution. So 1280 by 720. So that's what it's going to start out with. Now if somebody's screen is way bigger than that, what it's going to do, it's actually going to scale up this UI so that it fits their screen size. Or for some reason, if somebody's got like a really little mobile device, it's going to actually scale down as well. Now on the mobile devices, we do want to match width or height, and we probably want to match the height actually on this one. And our reference pixels per unit is about 100, which is fine. Our graphics raycaster basically means that we can actually touch things on the canvas. Alright. What we're now going to do is we're going to take our fixed joystick, click and drag onto the canvas, and there we go. Alright, we've now got this, and we can move this around in 3D space by using our pos X, pos Y. So I'm just going to kind of click and drag over to the left hand side, click and drag down into the bottom left hand corner. Now what I would recommend doing at this moment in time is going over to your simulator, rotate it, like this, and making sure it looks okay on the screen. This is what it currently will look like. I'd also recommend checking it out on a lot of different devices as well. So if it's, for example, an iPad 5th generation, this is what it would look like. As you can see, we're cutting out little bits of the side of the screen there. iPad Air, if it's an iPad Pro, Apple iPhone 11, we've got a little bit more of the screen there. We've also got this little bevel there as well, but we can definitely still interact with this. iPhone 6, yep, etc. So if it's a Google Pixel 3, it's going to show you what this is going to look like, and it's a pretty accurate representation as well. So just go through quite a few of them, see what they all look like. Make sure that it's not excluded in any way, or it's halfway through the screen or something. Yeah, okay. That's an interesting screen size. And that's the very last one as well. Okay, yeah, so I'm quite happy with that. So I'm going to go back to my Samsung Galaxy J7. And what I want to do is I want to make sure that this item is always targeted to the bottom left-hand corner. You can do so by using these anchors. And it's automatically done that for me, actually, bottom left. If I did top right, it would always be anchored to the top right of the screen. But bottom left means that if the screen gets bigger, it will always try and stay in the bottom left-hand corner, which is what it's doing. So let's take a look. Make sure that this script always stays switched on. You can change these items if you want, but I'm not going to. I'm quite happy with what I've got at the moment. This outer ring, at the moment, is a little bit too light for my liking, so I'm going to click on this and I'm going to make it a black ring. Okay. It does need to be a raycast target so that we can interact with it, and maskable as well. Then we get a handle on the inside. That's this little circle. Now what I'm going to do, I'm going to click on handle plane, and you'll see that you've got a whole bunch of different things. I like this handle ridged, so I'm going to drag that one in, and it looks a little bit more effective. Now because it's Halloween style, I want something that looks a bit more pumpkin like, so I'm going to click on this and I'm going to make it like a really interesting sort of orange colour. Once again, raycast target and maskable. Alright, excellent. That's it. We're set up with our joystick. So now it's time to actually write a script. Going to go back to assets, going to right click, create a new folder. I'm going to call it my script. Double click inside, right click, choose create, new C# script. This one I'll call it main. Just main. Alright, and it comes out as main.cs as a C#. Double click in order to open in Visual Studio. There we go. It may take a while for that to open. If this is the first time you're opening Visual Studio, give it the rights to get online, etc. And you will also have to log in using your Unity ID. Your version of Visual Studio might be like a white background. Well, I actually changed mine by going to, where was it? Me remember how to do this. I'm looking for properties. There we go. Properties window. Oh no, not properties. Okay, project, and looking for some sort of settings. Don't think it's options, tools, options, that's the one. Okay, and general, color theme, dark. Alright, that's all I've chosen there. You do get a bunch of different ones if you want to go with that. Okay, great. So this is what your general script looks like. They've already completed a bit of it for you. These are a couple of popular methods that are run. The start method runs when the game first starts, the first frame, and then never runs again. The update is called every frame. So if your game's running like 60 frames a second, the update will be called 60 times a second. That's going to be important for us. Okay, so let's begin then. So first of all, we need access to our joystick. So we're going to type public of type joystick that we're going to call joystick. Put a semicolon on the end to finish. Now what we've done there is we've simply made a slot that's going to be available in the inspector. By making it public, it means that it's going to be visible in the editor. If it was private, it won't be visible in the editor. Of type, when it goes green, it basically means it recognizes it as a type of a joystick, and we've given it a specific name. So if I were to save that now, wait for that to compile. So in other words, it's converting it into machine language or whatever it needs. Then I'm going to go to ground, I think, and I'm just going to drag main directly onto ground. Okay, that's it, and that's what we've created. We've created this little slot. Okay, now we can take our joystick, just drag it directly in there, so that now it can talk directly to that joystick. Now I need access to the camera so that I can move that, so public of type game object, and you can just press enter to autocomplete or return, and I'll call this cam. Okay, once again we've made another slot, so let's just save this. And then let's take our main camera, drag that into cam. So that's now what we're going to be manipulating and moving. Okay, and then what we need to know now is the rotation amount. So this time we don't need to define this in the inspector, so I'm going to make this private. It's going to be of type float. Float is basically a decimal number. I'm going to call this, right, let me start off with a lowercase letter. So rot, as in rotation, capital H, and then capital A, rot, A-H, amount. Okay, so in other words, rotation, horizontal amount. And I'm using camel case here, which basically means you start off with a lowercase letter, and every time you change the word, you use an uppercase letter. Whenever you're using these names, never leave spaces. Okay, it must all be one letter, and it's gone grey. The reason why is telling me it's not being used. Well, not yet, because I've not written anything yet, but it's good that it actually tells you whether you're using something or not. I'll do the same again, private float. This time it's going to be rot v amount. So in other words, the vertical and the horizontal. Okay, then I need to decide exactly how fast am I going to rotate. So this is going to be public, it is available in the inspector, we can change it in the inspector, of type float again, so it's a decimal number. I'll call this rotation speed. There. Press equals and set this to about 35. Okay, so that's exactly how fast we are going to be moving. Now, I'm not putting in the start, I need to put in the update because I need this to basically update literally every frame. And what I want to do is associate the rot H amount and the rot V amount with the movement of the joystick. So I'll say rot V amount to begin with equals joystick. And then as soon as we press dot, we get access to all of the properties that belong to the joystick, one of which will be vertical. Okay, so the vertical input is going to be passed through into this variable here, and it's going to store that number. Rot H amount equals, and you've guessed it, joystick dot horizontal. There we go. So we've just passed those values through. Now what we need to do is move our camera. So we can say cam dot transform dot rotate. Okay, and it's capital R. And then as soon as we open our brackets, it tells us exactly what it's expecting. It's expecting some Euler angles. Okay, so what we're going to do is we're going to pass in the minus rot V amount into the X. Okay, and I'm doing minus so that it's reversed. Otherwise, it's when you move right, you're going to move left. When you move left, you're going to move right. So I'm sort of reversing that. And then I'm going to multiply that by the rotation speed. Okay, so that's the speed at which it's then going to rotate. Furthermore, I'm going to multiply that by time dot delta time and put a comma. Okay, so time dot delta time basically means each and every second. All right, it's going to do that per second. If you don't put time dot delta time in there, what it does, it uses your frame time seconds. So if it's running at 60 frames per second, it will be running that command 60 times a second. If your mobile is running at like 2 frames a second, it'll be doing that 2 times a second. This ensures that it always runs at the exact same time on every device, always at exactly once per second. Okay, then in the middle, so if that's the X rotation value, this will be the Y rotation value now. I'm going to pretty much do the same, so I'm going to say rot H amount multiplied by rotation speed multiplied by time dot delta time. And then finally on the Z axis, I'm going to say 0. Don't want it to move at all on that axis. And just put a semicolon on the end. So let's take a look at that. So on our main camera, we have a transform that we've accessed, we've got a rotation that we've accessed, and we're saying move these values on the X and the Y according to however we're moving our joystick. Whatever values we have coming from there, we're going to pass through into this X and Y, and that's going to then rotate our camera according to that. Now at the moment it's not going to work correctly. I'm going to show you why, and then I'm going to give you a task, see if you can fix it. I will be showing you how to fix it, by the way, but for now that is going to get our camera working perfectly fine. Alright, so let me just click on ground, make sure that all of my slots are all perfectly filled. Make sure that none of those are saying none, because if any of those are saying none, you're going to get a red error, and it's going to be a null reference exception error that you get. Okay, so make sure that you're in simulator mode. We can press play. Our mouse is going to act like our finger on the mobile device. It's going to allow us to manipulate this. So let's press play. Here we go. So now when I move, I'm moving my camera, but if I move up, it does move up, but if I try moving both at the same time, whoa, check out what happened. I'm sort of getting this weird angle going on, which is not what you want. Alright, you want it always to stay straight upright, not to be doing this weird angle. So I want to give you a task. See by the next video if you can figure out a solution to get that fixed, so that when you move left and right, it moves left and right perfectly, and when you move up and down, it moves up and down perfectly. The two do not work together to get this weird angular motion that's going on.